Hi, so today we're going to talk about motors, generators, and electromagnets. In order to do so, we're going to have to go back and take a look at both Oersted and Ampere. Alright, so if we take a look at Oersted and Ampere, we can see their experiment right here. So this experiment on this side was done by Oersted, and what he was doing was he was preparing both an electricity and a magnetic demonstration. And then while he's running the electricity demonstration, he found that as the currents were traveling through this wire, it would actually cause this compass that was nearby to spin on their stand. And it would actually make a 90-degree turn compared to where that wire is. He wasn't really able to figure out what was going on, but it was a weird thing that bothered him, and he was trying to figure out what the connection was between electricity and magnetism. These two didn't interact with each other, so it wasn't like the compass was attracted to the wire or vice versa. Later, Ampere was actually doing a bit more of an investigation into what was going on. So he made these loops, and you can see here there's actually two loops, and they're actually going in the same direction. So the way they have the negative and positive set up, they both are in the same direction, and they found that the two loops actually attracted towards each other. He found that if you flip them upside down and you had one loop going in one direction, the other loop going in the other direction, then they would actually repel. So this was kind of the beginning of studies into how you can use currents to create magnetic poles. Alright, so now let's take a look at applying what we know. So we come back to this idea of a connection between electricity and magnetism. The first thing we're going to take a look at is an electromagnet. So in an electromagnet, we have to take a look at the electron. The electron is going to leave the negative side, and then it's going to head towards the positive side by going all the way through this coil of wire, and then heading through the positive, and then it gets boosted out, and then out the negative side back towards the positive side. They realized that you could use this nail now in order to use it as a magnet. So for example, if you had a paper clip right here, it would actually stick to this magnet that you've made, this electromagnet that you've made, and then it would be able to lift it up off the table. As soon as you disconnect the batteries right here or right here, then there's no more current, and then that paper clip would fall off. An example that you might think of is when you think of junkyards and how they pick up the cars. That's actually a giant electromagnet, right? So they're able to use a giant current in order to create a very strong magnet. So to summarize, if you have current, which is a movement of electrons, then you're going to have a magnetic field. So you're actually able to induce a magnetic field from electricity. Right, so now let's take a look at the side where we have a generator. And so if you take a look, a generator is actually giant coils of wires on the inside, similar to what we saw in the electromagnet. And just for scale, there's a person right here. So you can see this is actually much larger in terms of the size of your coils. There's also many more coils. And so they found that the more coils you added on, the stronger your electromagnet became. And this is why we use them as generators. The other thing that you're gonna have inside of a generator are some permanent magnets. So inside the coil of wires, there's a bunch of permanent magnets. And then the difference between a permanent magnet and an electromagnet is that one is permanent. So it doesn't need to be connected to a current in order to be a magnet. You need to have some sort of turbine. So for example, a wind turbine, or since we're in Alberta, if we're burning fossil fuels, that steam that gets created will also spin a turbine. That gets connected to the permanent magnets, and the magnets start to spin. And then what they noticed was that if you have movement and a magnetic field, you would actually induce a current. So this is actually how we get most of our electricity in the houses. There's a big generator somewhere that is creating tons of electricity, and then that gets connected to power lines that travel all the way to our houses and our buildings to allow us to have some alternating current. Alright, so let's take a look at a motor. So in a motor, you need to have some sort of power source. In this case, it's this alkaline battery, which is going to give us direct current. So one side will be positive and one side will be negative, and then you can see that the electrons will only move in one direction in this type of motor. You'll also need to have a permanent magnet, and so we should assume that one side is north and the other side is south. There's also your coil of wire right here, so that little loop is a coil of wire. In a large motor, you'll have many more coils of wires just right beside each other right here. And then this right here is a split ring commutator. And so you can see it looks like a ring. There's a split right through the center. These two are your brushes. So they just make sure that the battery is able to connect to the motor. Okay, so let's take a look at how the motor works. All right, so jumping down, we have our example of a motor. You can see the brushes are right here and right here. And so, like we mentioned before, the brushes are connected to the battery. So if I have a battery, it would connect here and it would connect here. And then importantly, we have a split ring commutator. So you can see this ring right in the middle is our split ring commutator. It allows the motor to be connected to the brushes and then out to your battery. You have your coil of wires on the inside, so you can see all around here. There's your coil of wires that are spinning around. And then the last thing you have are your magnets. So magnets, 2 permanent magnets, one north side facing the inside and one is south side facing the inside. Alright, so this next part's a little complicated, so if you're having trouble, feel free to pause and go back. But here's a zoom in so you can see once again the battery's here. It's going up through these wires to the brushes and then out this side. So once again, we have electrons flowing. You'll notice that every once in a while there's a split right here that hits the brushes, and so everything stops. So there's mostly current and then it stops, it's on again, off, on again, and off. Alright, so if you remember from our electromagnets, as long as we have movement and we have a current, you're going to create a magnetic field. So what's happening is every time the electrons travel, and the electrons will always travel in the same direction, you actually create this temporary magnetic field on the inside. So you can see this north at the top, which will always pull towards this permanent south. You'll get a temporary south pole, which will always go towards the north pole. The reason why you have this split in the middle of this commutator is actually because, if you think about it, every time north hits south, it would actually stop. And then every time south hits north, it would stop. So if you just had a complete ring in the middle, it would only spin 90 degrees over until it connected north and south, and then your motor would stop. Because of the split happens as soon as north hits south. It stops the current, which causes a motor to continue due to inertia, and then the momentum just spins it around until it's past the split, and then as soon as it's on again, the north pole faces up and then goes towards the south. And so you can see here with the arrows showing when you have attraction and repulsion, you have this commutator with the split ring, the brushes that mostly connect except for right when it hits a split. And so it'll either be attracting towards or it'll start to repel. So right now it's repelling away, north is going away, and then it attracts towards the south. As soon as it finishes attracting, you hit this split and then it stops. All right, now let's take a look at our St. Louis motor. So this is one of our most basic types of motors. So one of the first parts we're going to talk about are the terminals. The terminals are right along the top, and this is once again what connects to the battery. So you'll have one side that's connected to positive, one to negative. This connects down to the brushes. So you can see here the terminals will be touching the brushes. This is going to bring your electricity down to your split ring commutator. So you can see here there's 2 sides which are metal. This is actually that gap we were talking about. So right here it's plastic, it won't conduct. So if the plastic's touching, it doesn't conduct. The 2 sides on here are your permanent magnets. And so you'll always have one side that's north on the inside, one that's south on the inside. And then on the very center, you have your coils of wire, and that's your armature. So you need your coils of wire in order to create that north or that south pole that's going to attract or repel towards your permanent magnets. Alright, so let's go back and summarize everything that we learned. Okay, so let's start with our electromagnet. Our electromagnet is actually touching these 2 sections. So if you have current, which is the movement of electrons, you will generate a magnetic field. This is a really important concept for both motors and generators. The next part, if you talk about generators, then we're taking a look at movement and magnetic fields. So if you look inside the generator, there's a bunch of moving magnets near a large coil of wire. This allows us to have a current, so we're actually generating currents from this. The last one is motors. So motors is current as well as magnetic field. If you have some sort of current as well as some magnets, then you're able to create movement. So for a generator, you are actually changing from mechanical energy to electrical energy. The motor is the exact opposite. It requires electrical energy and then it converts it into mechanical energy. Alright, I hope this video was helpful and it gave you a summary in terms of motors, generators, and electromagnets. If you have any questions at all, please reach out to us, email us, and we'll get back to you as soon as possible. Alright, good luck this week. Bye, grade 9s.